All right, tonight's lesson is going to talk about proving parallelograms. When we prove that quadrilaterals are parallelograms, we're going to use those same theorems before that we said if a quadrilateral is a parallelogram, then these certain things exist. We're going to use that same stuff, opposite angles, opposite sides, and if they exist, then it's a parallelogram. We're going to use the converse of that logic to prove that quadrilaterals are parallelograms. So here are the theorems that we're going to use to prove parallelograms. 6.8, there's a 6.9, 6.10, 6.11, 6.12. 6.8 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if the opposite sides are congruent, it's a parallelogram. 6.9. 6.9 says that if an angle of a quadrilateral is supplementary to both its consecutive angles, it is a parallelogram. We'll talk about that in class tomorrow. Don't worry about writing that down tonight. I'll have that for us to write. Okay, that's interesting. I don't know how that's going to look on the video, but we'll see. 6.10. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I've got this angle congruent to this angle is congruent to this angle, so it's a parallelogram. If the diagonals of quadrilateral bisect each other, meaning that they split themselves in half, and their point they share in common is the midpoint of both diagonals, then the quadrilateral is a parallelogram. And then finally 6.12, which is a little different than what we've learned in the past. It's different from the last unit. If one pair of opposite sides of a quadrilateral is both parallel, so it has a little triangles there on it, and congruent, has the dashed line, then the quadrilateral is a parallelogram. So these are the theorems that we can use to prove that quadrilaterals are indeed parallelograms. So we have our example here. Determine whether the quadrilateral is a parallelogram. So first of all, each pair of opposite angles have the same measure, 115, 115, 65, and 65, and each pair is congruent. Since they have the same measure, they're congruent. So simply by theorem, I was going to fix that and I didn't, by opposite angles, so that's 610, by theorem 6-10, it is a parallelogram. Apology there for that little mistake. All right, next slide. So these are tests that we can use to test for parallelograms. If both pairs of opposite sides are parallel, by definition, it's a parallelogram. If both pairs of opposite sides are congruent, theorem 6.8, parallelogram. 6.9, if an angle is supplementary to its consecutive angles, it's a parallelogram. Both pairs of opposite angles are congruent, parallelogram. If the diagonals bisect each other, it's a parallelogram. It's hard to say. And if a pair of opposite sides is both parallel and congruent, it's a parallelogram. So these are the tests that we have for parallelograms. All right, find the measures, problem A. All right, opposite sides of the parallelogram are congruent. So for number problem A, I want to solve for x. So I'm going to do 6x minus 12 equals 2x plus 36. I'm going to subtract 2x from both sides. 4x minus 12 equals 36. Add 12 to both sides. 4x equals 48. X equals 12. So for the first answer, x equals 12. So my sides on this side will be 60. All right, now I'll solve for y. 4y equals 6y minus 42. I'm just going to subtract 6y from both sides. I get negative 2y equals negative 42, and y equals 21. And so here, if I put 21 back in there, that should be 84. So opposite sides of the parallelogram are congruent, so to solve for x and y, I just simply set them equal to one another. All right, now find the measure. Diagonals of parallelogram bisect each other. So again, same type of thing. X equals 5x minus 28. Going to subtract 5x from both sides. I get negative 4x equals negative 28. X equals 7. Solve for y. 5y equals 2y plus 12. Subtract 2y from both sides. I get 3y equals 12. Y equals 4. So it's simple problems because basically everything's congruent and you're just setting it equal to one another. The only difference would be when we look at consecutive angles, they're supplementary, so you'll add them together and set them equal to 180. You will be happy to know that that is your lesson for tonight. Hopefully it's under 7 or 8 minutes. And you can take notes on this. Tomorrow we'll go over 6-9. Tomorrow we're going to start talking about rectangles, rhombuses, and squares. And we may get into some other shapes, including kites. That's tomorrow's lesson, but for right now, this is your lesson for the night. Keep on working on your kites. I hope you have a good evening. I'll see you tomorrow in class.